Hello and welcome to our second video in the series called Succeeding in Fifth Grade Math. And today we're going to cover numbers as well as operations in base 10. Okay, let's start by understanding the place value system. So when you have a multi-digit number, let's say 5, 10, a multi-digit is going to have more than one number. You have to understand that a digit in one place represents 10 times as much as it represents in the place to its right, and 1/10 of what it represents in the place to its left. Let's look at the number 5, for example. If we were to multiply 10, then we would get the number 50, which is 10 times as much as the number to its left, which is 5. Now, if we took the number 5 and divided it by 10, we would get 0.5, and 0.5 is 1/10 of the number 5. So pretty simple to understand. Just know that when you multiply by 10, you're going to have a number that's 10 times the value of the number you started with. And when you divide by 10, you're going to have a number that's 1/10 of the value that you started with. Now, the second part of this is understanding patterns in the number of zeros of the product when you multiply a number by the power of 10. So simply, when you take the number 5 and multiply by 10, you get 50, and 50 has one more zero than 5. Now, when you take 50 and multiply it by 10, you get 500, which has one more zero than 50. And when you take 500 and multiply it by 10, you get 5,000. Sorry, small typo here. You're going to get 5,000, and that number is going to be has three more zeros than the initial number we started with, 5. So you go 5, 50, 500, and 5,000. So you really have to understand that every time you multiply a number by 10, it's going to increase the number of zeros. Now, also, we want to understand patterns in the placement of the decimal point when a decimal is multiplied or divided by a power of 10. So in this case, let's look at dividing by the power of 10. And essentially, when they say divided, that just means multiplying a 0.1, which is the same thing as dividing by 10. But let's look at dividing by 10 in this case. Now, 5 divided by 10 will give you 0.5. And what that means is initially the decimal point was on 5.0, right? If you think about it, it's 5.0. But when you move the decimal point one place to the left, it becomes 0.5. Now, let's say we take 0.5, divide that by 10 again, we're going to get 0.05. Go ahead and do that one more time. We're going to get 0.005. So you can see that 0.005 right here is drastically different than what we started with, 5, because we moved the decimal point 1, 2, 3 times over by dividing by 10 3 different times. So that's what you have to understand with the decimal point and dividing by that. Now, part 4 of this is using the whole numbers as exponents to denote powers of 10. So if I was doing 5 times 10 to the 0th power, we know that 10 to the 0th power is equal to 1. So 5 times 10 to the 0th power is just 5. Now, if we were to do 5 times 10 to the first power, we know that 10 to the first power is equal to 10. So 5 times 10 will give you 50. So we increased by 10-fold. We increased by 10 times, right, by multiplying by 10. Now, if we wanted to do 5 times 10 squared, we know that 10 squared is 100. So 5 times 100 will give us 500 in this case. So understanding that each of these exponents each of these bases of 10 can be written as exponents helps us realize that you're increasing 10 times every time. Now, let's go ahead and look at the fifth part of this, which is comparing two decimals to thousandths based on the meanings of the digits in each place, right? And we're going to use the greater than symbol, the equal sign symbol, and the less than symbol. Now, let's say we're comparing 6.81 to 6.37. We know that 6.81 is larger than 6.37 because of the because of the tenths and hundredths place. We know that 81 is larger than 37. So therefore, we're going to go ahead and say 6.81 is greater than 6.37. Now let's look at an opposite example of this. Let's say we're looking at a number that's less than, right? So 5.44. 5.44 is less than 5.55 because 44 is less than 55 when you look at the tenths and hundredths place. So in this case, we're going to go ahead and write 5.44 is less than 5.55. Now, finally, something they can try to do to trick you is add zeros at the end of numbers that are the same. So 5.75 is actually equal to 5.750. And similarly, 5.75 would be equal to 5.75000000. And that's why it's so important to know that the zero is just a placeholder. It doesn't change the value of the decimal. So just make sure you keep that in mind when you're solving these problems. Now, part six, and then we have one more part and we're done with this section, is being able to read and write decimals to the thousands using base 10 numerals, numbers, names, and expanded form. So when they say using base 10 numerals, that's basically understanding, 10, 100, 1000, which we already covered. Number names is saying like 347.392. That's being able to write it out. And expanded form, this is the one that I had to show you in person, or of course, on the Google Slides, because there's a very specific way of writing this. Now we have to go ahead and represent each digit by a certain script in math, and I'll go ahead and show you what I mean. So if we're looking at the number 347.392, we want to write that in expanded form. Well, let's start with the largest digit, right? The 300. So 300 is written as 3 times 100. And you can see every single thing here is written in terms of tens or 100s or 0.01s, etc. So we're going to go ahead and write 3 times 100 for this. So you're going to get 300. Then you have to include the 40, right? Because 347. So 300 is represented by 3 times 100. 40 is represented by 4 times 10. 7 is represented by just the number 7. So as you can see here, we've established 347 in this first part over here. Now we want to cover the 0.392. Really quickly before that, of course, just to cover the ones place, you do 7 times 1. You know how it's 100, then 10, then 1. So it's the 100th place, the 100th place, 10th place, and 1st place. Let's move on to the 10th place, right? The 10th place. So the 10th place here, it's 0.3. So we do 3 times 1/10. Okay, so we're gonna have, right now we have 347.3. Then we move on to the 100th place. So we do 9 times 1/100, which will give us 347.39. Finally, we go to the thousandths place when we multiply 2 by 1 over 1000, and we get 347.392. Just in summary, understand that you have to represent every single digit by its place, right? So we started at the hundreds place, then we went to the tens place, then the ones, the tenths, the hundredths, and then the thousandths. So understand expanded form, you have to include all of those steps. Now, finally, part 7, you want to use place value to understand how to round decimals to any place. This is pretty simple, but you still want to know. There was the generic rule that's always been true, right? 5 and up, you round up. 4 and down, you stay the same, right? So let's go ahead and look at some examples here. So if I want to round 7.7 to the nearest whole number, well, we look at 7.7, right? The 7 after the decimal point is above 5, so you round up. So you round up to 8, right? Pretty simple. Now let's say we have to round to the nearest tenth. We have 2.67. We look at the 6/7, right? And 6/7 is greater than 50, right? In this case, we're looking at 50 and above. So 67 is greater than 50, so you round up to 2.7, right? And that's rounding to the nearest tenth. Let's go ahead and round to the nearest hundredth. Let's say we have 4.563. Well, 4.563, so we look at 6.3, we know that the 3, unfortunately, is is not higher than 5. So as a result, we have to round down and we go to 4.560 or 4.56. So to the nearest hundredth, we look at this digit, the 3 digit, okay? And the 3 digit is less than 5, so we have to round down. Just once more, the 7 digit is greater than 5, so we can round up, right? The 6 digit is greater than 5, so you round up. Now, finally, let's look at this last example. We have 6.7942, and we're rounding to the nearest thousandth. Well, for the thousandth, you have to look at this digit, 6.7942. 2 is less than 5, so you're going to round down and go to 6.794. So the main idea is just to understand that you need to look at, first of all, what they want. Is it the whole number, the tenth, the hundredth, the thousandth? Once you establish that, you look at whatever value is in that place and figure out if it's greater than 5 or less than 5, right? And if it is 5, you're going to round up, just as a reminder, right? So that's what you really have to understand about the place value system in this case. Now, let's just cover this. I'm sure this is a more review than the last section, but we have to understand performing operations with multi-digit whole numbers and with decimals to the hundredths. So this part's pretty simple. The first part of this is just asking you to be able to multiply multi-digit whole numbers using a standard algorithm. So as we know, if we want to multiply 345 by 12, we have to first do 5 times 2 to give us 10, and then we have to do 4 times 2 to give us 8 plus 1, carry over from the 10, 9, and then 3 times 2 to give us 6, so 690. Then we go ahead and do the same thing on the bottom. Add a 0, 1 times 5 is 5, 1 times 4 is 4, 1 times 3 is 3. Add it all together, 0 plus 0 is 0, 9 plus 5 is 14, carry the 1, 6 plus 4 plus 1 is 11, carry the 1, 4,140. Don't want to go to too much depth on that. We've covered that before, or we haven't covered that, but I'm sure you've covered that before. It's just understanding how to multiply whole numbers. Now, this next part could be a little more tricky, and this is just understanding how to divide, up to 4-digit dividends and 2-digit divisors. That could be like 4,500 divided by 20, right? And then you would just follow the same procedure we see here for that problem. But let's go ahead and look at an example, right? That's pretty much what we're covering. Let's say we have to do 75 divided by 3. Well, first you want to set it up just like this, put the 3 on the outside, 75 on the inside, and we ask ourselves, how many times does 3 go into 7? Well, 3 goes into 7 2 times because the max can go in is 6 times. 3 times 2 is 6, right? So you write a 2 up top, you do 7 minus 6 to give you 1, and you go ahead and drop down the 5 because 3 doesn't go into 1, we know that, so we drop down the 5. So how many times does 3 go into 15? Well, 3 goes into 15 5 times, so you do 25. And then you go ahead and multiply 3 by 25 to give us, or you go ahead and multiply 3 by 5 to give us 15. So you wrap it up by doing 15 minus 15 is equal to 0. Pretty simple process, right? Divide the first one, multiply it, subtract it, bring it down, do it again until you get your answer. Now, this next part is going to be the part that you might be a little unfamiliar with, and they just want you to know how to add, subtract, multiply, and divide decimals to the hundredths. So let's understand how to add them first. If we had 31.80 plus 0.45, right, or 0.45, the first thing you want to do is line up the decimal, line up the decimal points. So it's just like a normal addition problem. Then from there, it's pretty simple. Just do 0 plus 5 to give you 5. 8 plus 4 to give you 12, carry the 1, you get a 2, and then 3 plus 0 is 3, 32.25. Pretty simple. Subtraction can be a little harder, but it's the same thing. First, line it up, 3.47 minus 1.59. Make this a 17, right? Because you can't do 7 minus 9. So 17 minus 9 will give you 8, right? And if you do that for 1, you have to do it for the next. 13 minus 5 will give you 8 again. So you have 8, 8, drop the decimal point, and finally do 3, you have to cross that out and make it a 2 because you did it for the last one. 2 minus 1, 1. So your final answer will just be 1.88. Pretty simple. Let's look at multiplication. Multiplication is a little more confusing, but it's the same process as before when we did, whole number multiplication, except you have decimals now. So let's solve it like a normal problem, right? Let's say we're doing, let's just call it 31 times 59, right? Same procedure. 1 times 9 is 9. 3 times 9 is 27. Drop a 0 right here. 5 times 1 is 5. 3 times 5 is 15. So we go ahead and add it all together and we get 1829. But understand that we have decimals here, so we have to know how to adjust it. Well, 3.1, that's 1 decimal place over. 5.9, that's 2 decimal places over. So whatever we're multiplying by is how we figure out how many decimal places we're moving. So if we have 1829, we're going to move it over 2 times to the left. 1, 2. So our final answer is going to be 18.29. So therefore, as we can see here, 3.1 times 5.9 will give you 18.29. Let's look at the last part of this and we'll be done for today. We want to find the quotient, right, of 55.318 divided by 3.4. Well, first of all, understand that 3.4 should go on the outside while 55.318 will go on the inside, and that's the standard form. Now, second of all, move the decimal point in the divisor and the dividend. This is the divisor, this is the dividend, right? And you want to move it over one place to the right, okay? Whenever you're solving the problem. So let's go ahead and just do it, and then I'll show you what I mean. So 34, right, goes into 55. Well, it goes in one time, so you put a 1 up here. Subtract the 34, and you solve it, and you get 21. 34 doesn't go into 21, so you drop the 3. 34 goes into 213 6 times, and 34 times 6 will give you 204. You subtract it, you get 9. 34 doesn't go into 9. Drop the 1. 34 goes into 91 2 times. 34 times 2 is 68. Drop the, do 91 minus 68 to get 23. 34 doesn't go into 23. Okay, drop the 8. 34 goes into 238 7 times. Okay, that goes ahead and evens itself out to give you 0. So we have 1627. Now here's the super important part, right? They say that you have to move the decimal point. So basically what we have to do is however much we move it in the 3.4 part is how many times we have to move it here, right? So 3.4 will move over, you get 34. 55.3 will move over, you get 553. So the numbers are directly on wherever the decimal point is directly below is where you'll put the decimal point. So since it's 553.18 here, 16 was before with the 553, and 27 was with the 18, right? So we go ahead and divide it with a decimal point in the middle, since we had to move it over once, right? So that's pretty much how you're going to solve these problems. The only tricky part would be the decimal point. Of course, you've done the normal division before, but you just want to understand that you move it over once here, so you get a whole number here, but then you also have to move it over once here to do the same thing. And that'll pretty much wrap us up for today. I hope you guys enjoyed the video. Just as a review, we covered understanding how to perform these operations with multi-digit whole numbers, as well as our understanding of place values. So give this video a like, subscribe if you're new to the channel, and I'll see you guys next time. Bye-bye.